Hello, I'm Natalie Rhea. Today I'll be discussing Lab 2, the second part of the charged tape experiment for Physics 2212. This presentation will include, first, an introduction of the lab with a description of relevant fundamental physics principles and the experimental setup. Next, observations, data collection, measurements, and interpretation of results from the experiment. A glow script model to visually depict the situation, and a concluding discussion. First, the introduction. The first physics principle at play here is Coulomb's law, which states that the electric force between two charged particles is equal to Coulomb's constant times the charges of two molecules divided by the square of the separation distance between the two molecules. Another important concept is Newton's three laws of motion. For the experimental setup, we first prepared two charged pieces of Scotch tape, referred to as U-tape, by quickly ripping two pieces of tape apart from one another. Next, we observed the interactions of the tape with each other and with neutral objects, such as our hands, and a negatively charged pen, when the tape was attracted to the pen, demonstrating that the tape was positively charged. Once the pieces of tape were charged, one piece of tape was suspended between two pillars. A second piece was brought near the suspended piece, causing the piece to be repelled and float upward. We then measured the separation distance between the two pieces of tape. In order to carry out calculations later in this lab, we had to make a few assumptions. First, we needed to ignore air resistance on a moving object. Next, we needed to assume that both pieces of U-tape had the same evenly distributed charge. Finally, in Lab 1 calculations, we represented the piece of tape as a point charge in the center of the tape, but in this lab, the tape is represented as a line of point charges spanning the length of the tape. Now on to the experiment. Our average measurement over the course of two trials for the equilibrium separation distance between the two pieces of tape was 2.75 centimeters. The length and mass of the U-tape, as well as the calculations of the force of gravity and electric force on the piece of tape, can be seen here. Because the pieces of tape are not moving, the system is in static equilibrium, so the electric force on the tape is equal and opposite to that of the force of gravity. In Lab 1, I rearranged Coulomb's law to solve for the theoretical charge of the piece of tape and the point charge system. As will be discussed more later in the video, this calculation will not be the same as the estimated charge in the more realistic line charge model. Lastly, I will show my glow script model of the floating tape system. When coding the model of the line charge system, I first initialized the constants and data gathered from our experiment. The variable named old Q is the theoretical charge of the piece of tape in the point charge system calculated in Lab 1. Once the rest of this model was coded, in order to reach equilibrium between the force of gravity and the electric force, this value needed to be changed because it was not accurate in the line charge model. The new charge value is variable Q. After initializing values, the E-field function written in Lab 0 was defined. This function can be used to determine the electric field of a point charge. Then the line charge function in the starter code was defined. This function creates a horizontal line of point charges. The function was called twice to make two lines of 10-point charges each, a magenta line representing the top piece of tape and a white line to represent the bottom tape. Next in the code, a loop ran that calculated the individual electric field and electric force on each point charge in the top piece of tape due to the bottom piece of tape. It also summed up these individual forces into one net electric force. Lastly, arrows to represent the total electric and gravitational forces were added to the model, and these values were printed in the text box. Here is my glow script model for the line charge model of the tape. The magenta spheres represent tape B, while the white spheres are tape A. Green arrows represent the electric force of each individual point charge that makes up the line of charges in tape B, while the yellow arrow is the total electric force on tape B due to tape A. The blue arrow is the force of gravity on tape B. The magnitude of the electric and gravitational forces are printed in the text box below. These values are equivalent because the system is in static equilibrium. Discussion questions. What if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. The calculated charge from Lab 1 of the point charge model was 1.283 times 10 to the negative 8th power. The value of the charge that resulted in static equilibrium in the line charge model from this lab was about 2.73 times 10 to the negative 8th power. Why did these estimates differ? Which value is more likely to be closer to the real value, and why? The line charge model is more accurate because it takes into account both the x and y locations of the charges on the piece of tape, while the point charge model from Lab 1 only takes into account the vertical distance between the two pieces of tape.